All right, Math 2 students, today we're going to learn how to multiply polynomials. Our goal by the end of the day is to know how to use 3 different ways to multiply a binomial times a binomial. So we're going to begin with what you know. You know about multiplying a monomial times a binomial because you've been doing the distributive property for years. So here's an example. If I have a monomial that's -2 and a binomial that's x plus 2, you know that the parentheses can be removed by multiplying the outside number by both of the inside numbers, the distributive property. So -2 times x is -2x, and -2 times 4 is -4, and that is the answer when you multiply that monomial by that binomial. All right, so the next question is, did this work in arithmetic? This is an important connection to make. So what if I want to multiply 3 times 11? Well, I already know that the answer to 3 times 11 is 33. But can I get that same answer by using the distributive property? You can. So my 3 is basically like a monomial, it is, and my 11 is 10 plus 1. Now it's just like I'm multiplying a monomial times a binomial, even though I'm just working with numbers and no variables. So now if I distribute the 3 times 10 is 30, and 3 times 1 is 3, and 30 plus 3 is 33. Same answer. So you can use the distributive property even when you don't have variables in your problem. Now, can you do this if you use 2-digit numbers? So if I'm going to multiply 12 times 14, if you don't know what the answer is, on a calculator, 12 times 14 is 168. But I'm going to use the same method I used on the last problem. What if I break this up so that it looks like a binomial? 10 plus 2. And I'm going to break this up into 10 plus 4. Can I do the distributive property and have my answer come out to 168? And you can. You just have to do the distributive property twice. So I'm going to distribute the 10, which gives me 10 times 10, which is 100, plus 10 times 4, which is 40, plus, now I need to distribute the 2. So 2 times 10 is 20, and 2 times 4 is 8. So now I know that 40 plus 20 is 60, so that makes 68. So 68 plus 100 is 168. So you can do arithmetic using the distributive property also, but you need to do the distributive property twice if you have 2-digit numbers. All right, so now we're getting right to it. What if they're not numbers? What if they're algebra expressions? So what if I want to do a problem like this? X minus 3 and x plus 4. What if I want to multiply this binomial times that binomial? Can I use the same method that I used here? Yes, you can. So I'm going to distribute the x, and x times x, this is x to the first and x to the first, which gives you x squared. Then I distribute it here, plus 4x. Then I distribute the -3, just like I distributed the 2 up here. The -3 gives me -3x. And the -3 distributed to the 4 gives me -12. So now when I multiply this binomial times this binomial, I got a polynomial that has 4 terms. And this polynomial has 4 terms, but it's not going to have 4 terms in its final answer because some of the terms are like terms. So if I look here, I only have one x squared term. If I look here, there's only one constant term. But I have a 4x to the first and a -3x to the first. So my final answer is going to have these 2 terms combined into one because they are like terms. Same variable with the same exponent, a 1. So I have x squared plus 1x minus 12. So when I multiply these 2 binomials together, I don't just get a numerical answer like I did with 168. When I multiply these two binomials together, I get a second degree trinomial for my answer. All right, so we just learned that with a little bit of work, we were able to take the distributive property that we already know. We saw that the distributive property works when you use regular numbers and don't even have any variables involved. And then we learned you can do that with two-digit numbers, which is like multiplying a binomial times a binomial. And then we tried it with algebra expressions, which was multiplying a binomial times a binomial. And so now we're going to launch into learning about the three different ways to multiply a binomial times a binomial. And you might ask yourself, why do we need to learn three different ways? And the reason is different textbooks and different teachers will call this different things, and they will do it in different ways. And unless you know all of them, you will not be prepared for their class, because they might use a vocabulary word that you don't know for something that you do know how to do, and you don't want that to happen to you. So you need to know all of these things. The method that we used on the last problem was the distributive property method. Okay, so this problem, we know it's a multiplication problem because it has a set of parentheses and another set of parentheses, and when you look in between them, there's no adding, there's no subtracting, there's no dividing. So the default is when you have parentheses with nothing in between them, it's a multiplication problem. And we're going to do this multiplication problem by using the distributive property method. So just like we did earlier, we're going to take this 2x and we're going to distribute it into the second set of parentheses. And then we're going to take the -5 and distribute it into the second set of parentheses, and we're going to see what we get. So I multiply here, and 2x times 2x is 6x to the second. 2x times 2 is 4x. Now I'm distributing the -5. -5 times 3 is -15x. And -5 times 2 is -10. So again, when I multiplied my binomial times my binomial, I ended up with a polynomial that has 1, 2, 3, 4 terms. And there's only one term that has an x squared. There's only one term that's a constant, but there are two terms that have an x to the first power. So we can put those two terms together when we write our final answer. So we're going to have 6x squared, a +4 and a -15 is a -11x. And then there's our -10. And that is the answer when you multiply 2x minus 5 times 3x plus 2. You get the second degree trinomial, 6x squared minus 11x minus 10. And that is the distributive property method. All right, the next method is probably the favorite method of most of my students. It's a way of doing the distributive property but keeping yourself very organized. So when you look back at your work, it's easy to see what the answer is going to be. So that is the table method of multiplying a binomial times a binomial. So since we have a binomial and another binomial, the table that we're going to make is going to be a 2 by 2 table. So our table is going to look like that. And on the bottom, we have enough space for this binomial, x minus 3. And on the side, we have enough space for this binomial, x minus 4. So now we're going to put each of our answers in these boxes, right? So we have an x multiplied times an x is an x squared. In this box we have -4 and x for -4x. In this box we have -3 and x. So in this box we're going to have -3x. And finally, this -3 and this -4 are going to make a +12. So again, when I multiplied the binomial and the binomial, I got 4 monomials. Now I'm going to write them down as a polynomial, except you might notice right now, there's only one x squared term and only one constant term, but there are two terms that have an x to the first. So those are like terms. So I can take these two like terms and I can combine them together. So they are only one term in my answer. So I'm going to have an x squared. When I combine these, I get -7x. And then I have a 12. So when I multiply the binomial x minus 3 by the binomial x minus 3 using the table method, I get this second degree trinomial, x squared minus 7x plus 12. All right, so for our last method of multiplying a binomial times a binomial, we are going to use the FOIL method. This method is probably the least liked by the students, but the most common in other math classes. So you really need to know what it means to FOIL something or to use the FOIL method. So here's a binomial, 2x minus 1. Here's another binomial, 3x plus 5. We're going to multiply those together by using FOIL. And so why is it called the FOIL method? We're going to get 4 monomials when we're done multiplying these two binomials. The first monomial is going to be the product of the first terms. The second monomial is going to be the product of the outer terms. The third monomial is going to be the product of the inner terms. And the last monomial is going to be the product of the last terms. So we multiply the first terms, then the outer terms, then the inner terms, then the last terms. So these words help to keep you organized, just like the table in the table method helps to keep you organized. So if we look at this binomial, there's the first term, and there's the first term. So when we multiply the firsts, we get 6x squared. Now, the outer terms, if we look at all 4 of our terms, 1, 2, 3, 4, this one is on the outside, and this one is on the outside. So when I multiply the outer terms, I get 10x. Now, if these are the outer terms, then these here must be the inner terms. So when we multiply the inner terms, we get negative 3x. And finally, if we look at all 4 terms in this binomial, that's the last one. In this binomial, that's the last one. So when we multiply the last, we get negative 5. And so there are our 4 terms. First, outer, inner, last, FOIL. We kept our monomials organized. So now we just need to write down our final answer. And so there's no other x squared terms. There's 2 terms that have an x to the first. So I'm going to put those together. That makes positive 7x. And there's 1 constant term. And so when I multiply the binomial 2x minus 1 by the binomial 3x plus 5, I get the second degree trinomial 6x squared plus 7x minus 5. So the goal of this video is to get you to multiply polynomials, specifically today, binomials times binomials, and to realize that there's 3 ways you can do it. You can use the distributive property, but you have to use it twice to distribute both parts of the first binomial. You can use the table method, which is a great way to keep yourself organized and not make silly mistakes. Or you could use the FOIL method, where you get your 4 monomials by multiplying the first, outer, inner, and last.